In Newton's second law, he defined a force that is proportional to acceleration, and that proportionality constant would be the object's mass. So in statics, actually the sum of the forces acting upon an object, so let's take an object, and the forces that are arbitrarily acting on this object at different angles maybe, we're going to say that the sum of the forces is equal to 0. And that's simply because we're going to be looking at static systems, meaning systems that do not move. So this very simple formula will help us solve a lot of problems. So this applies to any dimension. Since this is a force vector, we could split this up into components and define it in terms of scalar quantities. So what we can say, if we're looking at a three-dimensional system, or a three-dimensional inertial reference frame, we could have a force, we can define the axes x, y, and z with the right-hand Cartesian system. So what we can have is a particle. We have a particle, and there's several forces acting upon that particle in various directions in space. So there's force 1, force 2, force 3. And these lie arbitrarily in space. So what we can say is that the sum of the forces in the x direction is equal to 0. The sum of the forces in the y direction equal to 0. And the sum of the forces in the z direction equal to 0. Now, one thing to point out, we're looking at a particle. So that means we're looking at basically a point, meaning it has no dimension, and we're just treating it as a point. So the way that these forces interact, they lie in the same area or same point, so there's no ideas of torque or moments acting on this object. However, we will look at rigid bodies in the future and define torque and moments as well. But for now, we're defining that the sum of the forces in statics, the sum of the forces in every direction, x, y, and z, equals 0.